Let me start with a simple question. Large language models are powerful, but what if you want them to answer questions using your own data, your documents, your PDFs, and your internal knowledge base? That's exactly where RAG, Retrieval Augmented Generation, comes in. In this video, we are doing a hands-on lab exercise where we will build a generative AI application that uses our own data step by step. I'll show you how the data is ingested, how it is retrieved at query time, and how the language model uses that retrieved context to generate accurate responses. This lab is extremely important for real-world AI applications. And yes, it is highly tested topic in the AI-102 exam. Don't worry if RAG sounds complex right now. We will break it down, build it together, and by the end of this video, you will clearly understand how generative AI works with your own data. So, open your editor, stay with me, and let's build our first RAG-based AI application on Azure. Retrieval Augmented Generation is a technique used to build applications that integrate data from custom data sources into a prompt for a generative AI model. RAG is a commonly used pattern for developing generative AI apps, chat-based applications that use a language model to interpret inputs and generate appropriate responses. In this lab exercise, we are going to use Microsoft Foundry to integrate custom data into generative AI solution. So, the very first step in this lab exercise is to create a Microsoft Foundry hub and a project. So, the features of Foundry we are going to use in this exercise requires a project that is based on a Foundry hub resource. So, to begin with, let's open up a web browser and we are going to navigate to ai.azure.com. So this is ai.azure.com homepage and we are going to sign in using the Azure credentials. So I have successfully logged into the ai.azure.com using my Azure credentials. So this is how the homepage looks after we have logged in. I will close any unnecessary tips and tricks panels. Okay, so now we have to navigate through a section called as management center / all resources. So I have copied that direct URL for that section. So I'm just going to paste it. So that is ai.azure.com management center / all resource. Let me hit enter. Now here in this management center, I'm going to click on create new and I'm going to select AI hub resource. And then I'm going to click on next. Now I need to give a project name here and then I have to click on advanced option to make few more other configuration changes. So this is the project name I'm going to use and I'm going to rename the hub with a different name. So this will be my hub name, hub 589510006. So I have both my project name and hub name updated. Now let me click on the advanced options. In the advanced options, I'm going to keep the region as Sweden Central. I'm not going to make any changes to it. I'm going to change my resource group to resource group 1, which I already have in my Azure portal. Okay, so these are the configurations. We are okay with what we have right now. So I'm going to click on create. So this will take up a while to set up the Microsoft Foundry hub project for us. So we are going to wait for the project to be created, and once it is ready, we will navigate to that particular project. Okay, so the project is now created, project 589510006. So that completes the first part of this lab exercise. Let's move on to the second part, and that is to deploy models. So basically, we need two models to implement in our solution. First one, an embedding model to vectorize text data for efficient indexing and processing. And the second one, a model that can generate natural language responses to questions based on your data. Now, we are in our project, and inside this project, in the Foundry portal, we are going to select the model catalog, which is on the left hand side in the navigation panel. Now on the filter panel, we see something called as collections right here, right? So here I'm going to type in OpenAI, and that is the one which I'm going to select. So this will filter all the OpenAI collections only. Next, I'm going to search for a model that is text embedding ADA002. So this is a model. So I'm going to select it, and then on the details page of this selected model, we have an option called as use this model. So I'm going to click on that. So there is an option to choose direct from Azure models or manage compute. So we have to select direct from Azure models. Now we have to make some setting updates. So basically the deployment name, it is a valid name for our model deployment. I am not going to make any changes to this. We will leave that as is. So we have deployment type as global standard. Let me click on the customize here. And we are going to leave the model version as 2. Connected AI resource. We have to select the resource that we have previously created. And tokens per minute rate limit, we can leave it as 250k. That should be okay. And content filter is default v2. So let's click on the deploy. So there you go. Text embedding ADA002 model is now deployed. Now let's go back to the model catalog and repeat the same steps to deploy a GPT-4o model. So I'm going to select OpenAI under the collections, and then I'm going to search for GPT-4o. I'm going to select use this model, direct from Azure models. We leave the GPT-4o as a deployment name, global standard as deployment type. Click on customize. Hopefully no changes to any of these options. Let me click on deploy now. So there you go. Both of our models are now deployed. If you want to verify it, we can go here under models and endpoints. We should be able to see both GPT-4o and the text embedding ADA002 deployed to our project. So that completes step number 2 in our lab exercise, that is deploying models. Now let's move to the next step, that is adding data to our project. The data for our application consists of a set of travel brochures in PDF format from like fictitious travel agency, let's call it as Margie's Travel. Let's add them to our project. So for that, I need to open up a new browser and navigate to Microsoft Learning. They have provided a particular example files. So I have the web link to that particular brochure zip file. So I've copy pasted that. I would hit enter now. So that's downloaded into my machine. Let me unzip that and have the files ready. Okay, so as you can see, there are multiple locations: Dubai, Las Vegas, London, so many information about the Marquis Travel Company. So this is our base data, and we are going to upload this to our project. Now let's go back to the models and endpoints Microsoft Foundry page. Now in the Foundry portal, in our project under the My Assets, we have an option called as Data and Indexes here. So under this, we have an option to click on New Data. So let me click on that. Okay, so we are in the pop-up pane which says Add Your Data. So here I'm going to, under the Data Sources, there is a drop-down. I'm going to expand the drop-down menu, and I'm going to select Upload Files and Folders. And then I will select Upload Folder, and I'm going to select the folder that we have just unzipped, that is a brochures folder. I'm going to click on upload. Yes. So we'll wait for the folder to be uploaded, and we can see it contains several PDF files as I have shown you earlier. So that completes adding data to our project. And yeah, there was one more step, that is we need to give a name. So I'm going to give it as brochures, and then let me click on create. There you go. Now the data is uploaded for this particular application. Now the next step is to create an index for this particular data that we have uploaded. So now that we have added a data source to our project, we can use it to create an index in our Azure AI search resource. So in the Foundry portal, in our project, on the left side navigation pane, under the My Assets, again, we have an option which we have seen earlier, data and indexes. So let me click on that. And we can see the data files. Under the data files, the brochures is the data that we have uploaded in the previous step. Now there is another option called as indexes. So let me click on that. Okay, so under the indexes, we have an option called as new index. So let's click on that new index. And under the data source, we need to select a data source. So the option for that is data in our Foundry. So data in Azure AI Foundry. And here we have brochures, which we have already added in the previous step. So let me select on the brochures, and then we can click on next. Under the index configuration, there is an option called as select Azure AI search service. So we are going to create a new Azure AI search resource. So let me click on that. So it has taken me to the Azure portal where we need to create this particular search service. Okay, so under the create a search service in the Microsoft portal, I have to give a service name. So I'm going to use AI search 58951006 as a service name. I'll leave the location as Sweden Central and pricing tier as basic. So let me click review and create, and then create. So let's wait for the AI search resource to be created, and then we can go back to the Foundry. So yeah, the deployment is complete. My search service is now ready. So let's go back to the data and indexes. And now here under the select AI Azure search service, let me click on connect to the other Azure AI search resource. Yeah, so this is the AI search service that we created from the Azure portal. It's called as AI search 58951006. So I will add that as a connection. Okay, now that connection is available. I'm going to select it, and under vector index, I'm going to type in brochures -index. Okay, and under the virtual machine, I'm going to keep auto select and then click on next. Under the search setting, now the vector setting, add vector search to this search resource. I am going to leave that selected. Under Azure OpenAI connection, we'll leave the default Azure OpenAI resource for our hub. So that is the only option we have. And under the embedding model, we already have that text embedding ADA002. So that is the one I'm going to select. And the embedding model deployment, I'm going to choose the one which we earlier deployed. Okay, and then click on next. So review and finish. Let me click on create vector index, and we'll wait for the indexing process to be completed, which usually takes a while depending on the available compute resource in our subscription. So all you need to know is in the index creation operation, it consists of the following jobs: crack, chunk, and embed the text token in your brochure data. Second step is create the Azure AI search index. And the last step is to register the index asset. As you can see, we are currently on step number 1, where it is saying allocating compute resource, which is in progress. Soon it will move to step 2 and then step 3, and the indexing process would be then completed. So while we are waiting for our index to be created, what we can do is we can look at the brochures that we have downloaded, and we can get familiar what the data it contains. So I'll go back to my brochures folder. So it's called as Margie's Travel Company, and they have travel brochures for Dubai, Las Vegas, London, New York, and San Francisco. So if I open Margie's Travel Company, so yeah, as you can see, they arrange travel for Dubai, Las Vegas, London, New York, and San Francisco, and employs best travel experts in the world. Their leadership team consists of 4 people, and they provide services like flights, accommodations, transfers, visas, currency exchange, and excursion. So yeah, we can maybe ask few questions based on the data we see here to the model, and let's see how it responds. So we are still in the step number 1, that is cracking and chunking. So yeah, let's keep waiting. All right, step number 1 is now completed, that is cracking and chunking. We are into step number 2, and that is also completed now. That was creating Azure AI search index. Now we are going into step number 3, registering index. All right, so as you can see, all the 3 steps are now completed, and the status of this particular brochure index is also showing as completed. So that completes our step in this lab exercise, which we called as creating an index for our data. Now let's move to the next step, that is testing this index in the playground. So before we use this index in a RAG-based application, we need to verify that it can be used to affect generative AI responses. So in the navigation pane on the left-hand side, let us click on the playgrounds and then open the chat playground here. On the chat playground page, under the setup, I need to ensure that we select GPT-4o model, which was previously deployed. So it's already selected. So that's the only model we have to select. Then in the main chat session panel, we are going to put up a question. Let me say, where can I stay in New York? Remember, New York was one of the locations that this travel agency was supporting. Now, as you can see, the response given by the model for my question, where can I stay in New York, it is very generic, and it doesn't look like it has come from the brochures that we have uploaded, right? This is because we have not added the data into this chat playground yet. So let's do that next. In the setup pane on the left hand side here, we have an option called add your data. So let me click on it, and then let me add the brochure's index. Okay, and then I'm going to select the search type as hybrid vector plus keyword, so we'll not make any changes to it. So now, as you can see, a new chat session has started after we added the index. Let me ask the same question again. and let us see what response we get now. So the very first line itself indicates this has done some sort of reference to the documents that we have uploaded. So the first line says Margie's Travel offers the following accommodation options in New York. So now the response from the model is not generic. It is based on the documents that we have uploaded into the project. So as you can see, it is giving only three options: the Manhattan Hotel, the Grand Central Hotel, and the Park Hotel. And it also tells it has referred the New York brochure. So this is now working perfectly as a part of our RAG application. Okay, so now that we have tested this model and the brochure index in the chat playground, the next and the final step in our lab exercise is to create a RAG client application. So now that we have a working index, we can use the Azure OpenAI SDK to implement the RAG pattern in a client application. So we are going to explore the code, how we can accomplish this in this particular example. All right, so let's return back to the browser where we have the portal.azure opened. And here I'm going to select the Cloud Shell. Let me expand it. Let's choose the option PowerShell. So the Cloud Shell is being initialized. So let's wait for that to complete. Okay, so one additional setting that I need to make is under the setting option here, let's go to the classic version. So this will allow me to edit some of the code files. Okay, so the Cloud Shell is now ready for us to explore. Let me clear the screen first. Okay, so I have cleared my screen. Next, I need to download the code files, which is already available in the MS Learn GitHub repository. So we'll be using the git clone command to download those. So this is the git command. So this will clone the Microsoft MS Learn AI Studio folder repository. Okay, so let me navigate to that folder, lab files and Python. Okay, let me list out the files. So as you can see, there are two files, rag app.python script and a requirement.txt file. So now in the Cloud Shell command line pane, we are going to enter some commands which will install the OpenAI SDK libraries. So as you can see, I have run the command pip install -r requirement.txt OpenAI. So basically the file requirement.txt, it has some required modules. So I'll show you that. So as you can see, the requirements was python-.env. So this was installed along with the OpenAI. Next, I'm going to type in code.env. So this is an environment configuration file. As you can see, there are multiple options here: OpenAI endpoint, OpenAI key, chat model, embedding model, search endpoint, search key, and index name. So OpenAI endpoint. So this is the OpenAI endpoint from our project's overview page in the Foundry portal. So that is in the overview page under the Azure OpenAI. So this is my Azure OpenAI endpoint. So let me copy that, come here and paste it. Next is Azure OpenAI key. So this is the OpenAI key from our project again under the overview page. So this one here. Next is my chat model, and this is the name which we assigned to our GPT-4o model deployment. We left the name as GPT-4o itself, and the embedding model. So this is the name we assigned to our text embedding ADA002. So that is again text embedding hyphen ADA hyphen 002. The search endpoint. So this is the URL for our Azure AI search resource. So this we are going to find under the management center here. Okay, so these are the connected resource in this project, and what we are looking for is our search endpoint. So we need to get the URL for that. So this is my search endpoint. And next, the search key. It is again we can find under the management center. And lastly, the index name, we have named it as brochures hyphen index. Okay, so all of our variables are now updated. Let me save this and exit out of here. Next, let's explore the code, which is rag-app.py. Right, so this is the code which we have cloned from the Microsoft Learn GitHub. And as we review the code, we can see this code creates an Azure OpenAI client using the endpoint key and the chat model. It also creates a suitable system message for a travel related chat solution. And it also submits a prompt including the system and the user message based on the user input to the Azure OpenAI client. And it is adding connection details for the Azure AI search to be queried. It adds details of the embedding model to be used to vectorize the query. And finally, it displays the response from the grounded prompt, and it adds the response to the chat history. Okay, so there is no much changes we have to do. It's all updated code here. So let me right click and quit. Right, so we are now ready to run this chat application. Okay, so let me type in python.rag-app.py. So this will execute the code. And let's enter the question which we had asked earlier, and that is, where can I stay in New York? So as you can see, the output from this testing is again reflecting the same output that we had earlier got from the chat playground, and it is referring to the Margie's travel offers, the travel documentations for the New York, which is good. Let me ask another similar question, that is, where can I stay in, let's say, Delhi? So Delhi was not a location which was part of Margie's travel offering. So this should give me a negative response. Yep, as we expected, the requested information is not available in the retrieved data. So for a generic chat model, when I type, like for example, to a chat GPT or Copilot, when you ask where can I stay in Delhi, it would have given you a whole lot of information. But this is a model, or this is an application which is now grounded with a RAG data, or our own company data, which is Margie's travel agency data. And they don't support travel to Delhi. So when I asked where can I stay in Delhi, it is saying that requested information is not available, and that is exactly what we would expect the application to do. All right, that brings us to the end of this lab. Today, we have built a generative AI application that uses our own data using the Retrieval Augmented Generation, or RAG pattern. You have seen how documents are ingested, how relevant information is retrieved at query time, and how that context is passed to the language model to generate accurate grounded responses. This architecture is incredibly powerful because it allows you to use large language models without retraining them, while still keeping responses relevant, up to date, and based on your data. I would strongly encourage you to pause here and experiment, add more documents, change the queries, or tweak the retrieval settings. That's where the real understanding kicks in. From an AI-102 exam perspective, this lab helps you clearly understand one of the most important real-world patterns Microsoft expects you to know. In the next video, we will take this further and explore more advanced generative AI scenarios, specifically fine-tuning and model in the Azure AI Foundry. If this lab was helpful, don't forget to like the video, subscribe to the channel, and share it with others preparing for AI 102. Thanks for building along with me, and I'll see you in the next lab.